Hi guys, welcome back to my channel once again. My name is Ayush and in this video we are going to solve the question that was asked in a Google interview question and also in LinkedIn as well. Now this question is based on a SQL problem that I found on LinkedIn. Okay, that's ironical, but I will show you where. Now if you visit this person's page, by the way this guy's name is Nishant Kumar and he's currently working as a data engineer at IBM as of 4th May 2026. If you visit his page, by the way, he has 1 lakh followers. Okay, so you can imagine how good his content is going to be on LinkedIn or on any other platforms. Okay, now if you go to his activity page here, and okay, you will see, if you go to the activity page here, you will see that recently he has uploaded a post in which he has given us 79 SQL interview questions that one can practice to develop their skills and to be interview ready for any data role. Okay. And out of these 79 questions, I have already solved 2 questions and uploaded those videos earlier. You can check them out on my channel as well. And but watch this video first and then go back to watch those 2 previous videos. Okay. Now in this video, we will be going to solve the question number 68. As already told earlier, I won't be solving all the questions, but only those questions that I find are of on a difficulty level on a higher difficulty level, basically between the range of medium to hard or a little bit above harder as well. Okay, so I've opened this question here, and this question was asked in Google and LinkedIn as well. And this is the question with the schema and dataset. I have put this question and the schema and the dataset in a better format on my Notion template. So let's bounce there to check what the question is. Okay. So this is the question, and this is the problem statement and the create and insert statements. I will explain it to you in just a while. Before that, let me tell you something really important. I will put the create and insert statements in my description box as well. And after understanding the question, I want you guys to try it on your own because this is really important. Just watching the solution won't help you learn about how problem solving skills are used in SQL. Okay. Skills like logical reasoning, problem solving are really, really important if you are applying for any kind of data role. And not only just for solving SQL, but for solving day-to-day activities in your professional career, right? So it is always advisable to take some time and solve these questions by yourself also. Now, this time may range from anywhere between 10 to 15 minutes to even an hour. Okay, set yourself a particular threshold. For example, if you are solving a question, solve it for an hour. If even after an hour you are not able to solve it or even reach a basic or an optimum level, like just you have half solved it or something, if you have not able to reach that level as well, completely forget it, go to the solution and then watch it. Why this helps? Because when you solve a question by yourself, you have a deeper understanding of the problem. You are able to go into the depth of the problem and understand and imagine what the problem is actually about. Okay, like when you read a problem, you understand what, okay, this is our input table. Now we have to convert this input table into this output table. How my output table should look like? What are the functions that I have to run to come from this to this, to basically come from point A to point B? Now, this is what here is important. And if you do not perform this action, it won't be of any use to just watch the solution. Okay, so this is really, really important to solve the question by yourself. Even if you are not able to solve it, it's good. Not solving a question at all is way worse than solving a question and not reaching the solution. This is something that you need to imprint on your mind. Okay, I guess I've already told a lot, and let's jump to the problem statement. Okay, the problem says, for each passenger, find the average absolute fare difference between them and all other passengers that satisfy all of the following conditions. Okay, so these are certain conditions like passengers are in the same class, they are non-survivors, and their age difference is less than 5. Okay, and do this for each passenger. Okay, for example, we have 4 passengers A, B, C, D. Okay, and other details are given. So for A, we need to compare it with B, C, and D and check if all those conditions which are given in this question are matching or not. That this is just what we need to do. Okay, this question is really simple. It is not actually a hard question, it seems, but if you like on the surface it looks really hard, but if you just calm down a little, read the question thoroughly, and internalize it, what the question is asking, then it becomes really, really easy. And not only this problem, but any kind of SQL problem. Okay, so here is the schema and dataset. Again, as promised, I will put this in the description box so that you yourself can run this in your SQL database and try solving it by yourself. Here's a sample input. I would like to explain what is happening here. Okay, so in this sample input, we have 5 passengers and only 2 are in our output. Why? Because for Tom Harris, we compare this with all the 4 of the passengers. Okay, now we only want people who have survived. Okay, so we don't want to see Peter Hall. We can ignore everything about passenger ID 5. Okay, and also if you see with Tom Harris, with Jane Clark, the age difference is 2, which is under our condition. Both are non-survivors. And okay, we need to find a fair difference, which is 80 minus 60. We have 20. Okay. Now Tom Harris and Mark Evans, that age difference is 15, which is not satisfying one of our 3 conditions. Just for reference, these are the 3 conditions. They have to be in same class, they have to be non-survivors, and age difference should be less than 5 years. Here the age difference is 15 years, so we will not consider Tom Harris with Mark Evans. Similarly, for Tom Harris and Lucy Grant, their P class is different. Okay, so we can't even consider them as well. Also, their age difference is 10. Again, it satisfies none of our conditions. Okay, so with Tom Harris, only Jane Clark is there. Similarly, if you check further, then Jane Clark also only matches with Tom Harris. Okay, Jane Clark, when compared with other 4 passengers, only matches all the conditions when compared with Tom Harris. So that is why our sample in our output, only these 2 names will come with their average absolute fair difference. Okay. I hope you understood the question here. If you didn't understand, please rewind the video and read the question again by yourself and go through my explanation. You will surely understand it. Now we will move to the PostgreSQL. I will have to change my windows and I'll have to change the windows in my OBS. So I will see you in my Postgres pgadmin 4. Now, this here we are on our pgadmin 4, and you can see that this is the table Titanic, and I have already run the select statements just for you to see the table here. I guess the bottom right hand part is not visible, but okay, that is not the issue here. Okay, so wait, let me extend this. Okay, now I guess you are able to see the names of the passengers, their P class, survival rate, age, fare. Okay, and again, these details are something that we do not want, but again, it is in the table, so we can't do anything about it. Now, how to approach this? Since the first thing that we need to do is compare one passenger with others, the best thing to do here is to inner join both the tables, right? Or popularly it is called a self join. So what we will do is we will run Titanic T1 inner join Titanic T2 on what? On T1 not equal on T1 dot name not equal to T2 dot name. Now, here is one important thing that you need to understand here. Okay, I would like to take an example. Okay, this is a very small concept, but really important concept, and I would like to take my time and make you guys understand what I'm talking about here. Okay. Okay, sorry. I thought I'm on Python. Okay. Now, let's say you have a table named A, B, C, and D. You have a table with you have a column with these 4 columns. I mean these 4 rows, and you are self-joining it with the condition that T1 is not equal to T2. Now, what will happen? Let's take it down further. Now, when you join A, now each row will be joined with another row. Only those names will not come which are similar. Okay, so A will be joined with B. Again, A will be joined with C, and A will be joined with D. Now, when B will come, B will be joined with A, then with C, and then with D. Similarly, C will be joined with A, B, and D will be joined with A, B, and C. Okay. Now, with this, you will get 12 combinations. Now, one thing you must have noticed that there is a kind of duplication here. Like we have A B pair and B A pair. Here comes the concept of ordered pairs and unordered pairs. Okay. Now, how will you how to identify if this question requires to find ordered pairs or unordered pairs. Basically, let me tell you, these are unordered pairs. Okay, if we only had considered, let's take CB and C. Okay, let's now consider D for the sake of calculations. Okay, assume that these are our pairs and we do not have a passenger named D. Okay, so these are our unordered pairs. Okay, if there were ordered pairs, it would come as, it would be like A will be joined with B, like B, and A will be joined with C. Now, when B will be joined, B won't be joined with A. If we have to find the ordered pairs, then if B is joined it with A, it won't be any ordered pair. Okay. For that, we have to join B with C. And C won't be joined with anyone because with C we have already made pairs with A and B. Okay. So this is the concept of unordered pairs and ordered pairs. Okay, I hope you guys understood the concept here. Now, to identify if unordered pairs is required or ordered pairs is required in this question, if we remember, then we had to compare each passenger with the other passengers. Okay, if we take the example of this table, then A had to be compared with B and C, and B had to be again compared with A and C. So even if there is a case of duplication, that doesn't matter because all the entities are different, and we have to compare one person with another person even if they are compared earlier. If you remember our input table, I mean sample output table, if you rewind this video, you will see the sample output table. You will see that Tom Harris, like both the persons had appeared even after they were compared two times. Like A was compared with B and B was compared with A. And in the final output, we had only A and B as well. So this is the concept that I wanted you guys to understand. And with this, you will understand that we have to calculate unordered pairs here. Okay. Now, if you wanted to calculate unordered pairs, then you always use T1 dot column less than equal to T2 dot column. Okay. T1 and T2 are name of your tables, and these columns are the same similar columns. But if it's about unordered pair, then you will do T1 dot call less than T2 dot call. Okay, you will use either less than or more than. Why? Because if you see this, here the condition of less than satisfies completely. A is less than B, A is less than C, and B is less than C. Okay, so in short, if you want ordered pairs, use less than or greater than sign. If you want unordered pairs, use unequal, not equal to sign. Okay, I hope you guys understood this concept because it is a really important concept, and I wanted you guys to understand it. Okay. Now our names are unequal and we need to put some conditions here as well. Okay. What are the conditions? That is class has to be same. So let's put T1 dot P class equal to T2 dot P class, and the age difference should be less than equal to 5 years. We will find the absolute age difference because like there are chances, right, that for example, okay, we have not joined this table. If, like, let's say we are comparing John Smith and Mary Johnson, 35, okay, sorry, Mary Johnson and James Brown. If we do 30 minus 40, it will come as minus 10. And we do not want the age difference to be minus 10. Why? Because we only want the age difference to be less than equal to 5 years, but in positive manner. Okay. So we will use the absolute function, which is the ABS function. And we will do T1 dot age minus T2 dot age, and this should be less than equal to 5. Okay, with this we have completed all our conditions. Only one more condition is left, that all of them have not survived, where survived is equal to 0, where, and we do not have to use it in the join condition. We can just filter it out in our where condition, where T1 dot survived equal to 0 and T2 dot survived equal to 0. Now with this, all our conditions are done. We have filtered it completely. Now we can create a CTE out of it with CTE as, wait a minute. Okay, so there are some disturbance over there. So I have to check it out. Again, no worries. We can create a CTE out of it here. And now let me show you what the CTE looks like. So let's start. from CT. Now here we have filtered everything, and you can see that each passenger is compared with other passengers as well on the basis of their conditions. Okay, you will see that there are duplicates. For example, for John Smith, you have Mary, David, and Alice. Okay, so if we check for Alice, which is in the last row, you can see John Smith is again there. Okay, so there will be duplicates, and this is what we wanted. Okay, now just one last step is left, that is to calculate the average fare difference. Okay, now we will do select name average of, again we will use ABS. Okay, now one thing I would like to do here, we will not select all the columns in our CT. Why? Because we only want this name column, either this name column or this second name column, both are same. Okay, that is nothing to worry. But the problem here is the pair. Okay, because if let me do let's because in CT both the pair columns have the same name. You can see here also the column name is fair, and here also the column name is fair. So what I will do is I will select t1 dot name as name, t1 dot pair as pair A, and t2 dot pair as pair B, so that we have different names for the pair columns. And now we will use the function here, pair A minus pair B as average pair diff. And since we are using average, we will use group by name. Now if we run this, we will get our answer. And just if you want to verify, you can go to that LinkedIn post, and in that LinkedIn post they have also uploaded the outputs there. If you check, the output for both are same. Okay, now I would have ended this video here, but I wanted to share one more thing, which is query optimization, which is something that we could have done here with ease. Okay, like we didn't have to create a separate CT here. How? If you can see, then we can just remove this alias. We do not need this, and this average function we can easily use here. Let me show you how. We do not need this pair A as well. We can just replace it with this, and this we can use this alias here as average fare difference, and at the end we can group by t1 dot name, because we are since selecting only one column here, t1 dot name. Okay, we don't want this and this, and if you run this, the answer is same. Okay, you can check it by rewinding the video. You will see that both the answers are same. So in this way, we can optimize our query as well. We didn't have to create a CT, then put another select statement. In just one query only, we could have answered both the questions. I mean, our requirements. So with this, we reach to the end of our video. I hope you really like my solution here. If you like my approach, please consider liking this video and sharing this video with your friends who are preparing for interviews where SQL questions are asked. And also put your comments in the comment section, because it acts as a motivation for me to post new videos and bring different type of content for you. Until then, goodbye and happy learning.